Started by you. Let everyone know that you are being recorded and transcribed. That is the private policy. Implicit functions. At the end of this learning unit, you should be able to differentiate implicit function. Can someone tell me what is an implicit function? Or do we know what implicit function? Yes or no?
No.
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 Okay, since
Isn't
there's
it
so many
deriving-
no's,
Impossible to solve.
not
Isn't it
really
deriving?
impossible.
It's deriving your x variables, but you're also deriving your y variables with respect to x.
Okay, so now instead of, let's forget about deriving. What is implicit function? What is an implicit function? Forget about deriving.
Isn't it written in terms of a function written in terms of x and y?
Is this an implicit function? Y plus x is equals to 2.
No, because you can solve for both y and x, can't you?
So x squared plus y is equals to 2. Is that an implicit function?
Implicit function is when we can solve using chain rule or product rule.
Yes, but then is this an implicit function? X squared plus y equals to 2. Is it an implicit function?
No, because you can express y in terms of x as it's 2 over x squared, or 2
Okay.
minus x squared.
So let's start there. What is an implicit function? They say in algebraic equations, in x and y, if an algebraic equation in x and y can be expressed in the form of y is equals to x, right? Meaning if you have x squared plus y is equals to 2, and you can write this as y is equals to 2 minus x squared. For example, y is equals to 4x squared plus 3x plus 2. Such a function is referred to as an explicit function. Are we all together?
Yes, ma'am.
Right?
Yes.
Now they say, if it is not possible to express y directly in terms of x, the function is called implicit. Does it make sense now?
Yes.
Meaning that
Yes.
if you have something like this, x squared plus y squared is equals to 2. You can't write y is equals to 2 minus x squared. Or y is equals to 2 the square root of 2 minus. You'll end up having a plus or minus y is equals to whatever. Does it make sense now?
Yes.
Yes.
So therefore, we call those functions implicit functions. Example, y is to the power of 7 plus 6 xy to the power of 6 plus 1 equals to 0 is a relation between y and x, but it's practically impossible to express y directly in terms of x. In our module, did you hear what I said?
Yes, ma'am.
Yeah.
I'm saying in our module, MAT2691, it's impossible to express it. So now in the bracket, they said infinite series can be used, but it's outside the scope of this syllabus. So that's what they're saying. In our module, we can express this as y is equals to whatever on the right with only x values on the right. Therefore, we call that an implicit function. We are now together, né? So now they're saying the following examples will illustrate how dy dx can be found in the case of an implicit function. Relation connection to x and y. However, the following first to be noted. Now they're saying the derivative of y with respect to x is written as dy over dx. Do you see that? Yes.
Yes.
Now they say the derivative of y squared with respect to x is written as 2y dy over dx. Does it make sense?
Yes.
Yes.
Okay. Now the derivative of y to the power of n with respect to x is this. Does it make sense?
Yes.
Yes.
Yes, ma'am.
Now let me tell you something. Here you see that you have x to the power of n, y to the power of m, isn't it? Because you are differentiating implicit what's this? You are using implicit differentiation. This you'll use a chain rule on this one. I'll show you with an example. Sorry, this is the product rule. It's not a chain rule because you're saying x to the power of n times y to the power of n. So this is the chain rule. Now, one thing about implicit differentiation, listen to this. If you differentiate y, you multiply by what? dy over dx. Does it make sense what I'm
Yes.
saying?
Yes, ma'am.
Can you please
What is the
repeat?
derivative of x squared?
2x.
2x, right?
Good.
The
Yes.
same thing. Every time you differentiate y, you will differentiate it the same way you differentiate x, but after differentiating it, you multiply by dy over dx all the time in implicit differentiation. That's what they're saying. Makes sense?
Yes.
Yes, ma'am.
Yes.
So what is the derivative of y to the power of 3?
3y
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 squared.
times
dy dx.
3y squared x.
Thank you. 3y squared times dy over dx. Every time you in implicit differentiation, every time you differentiate y, you differentiate it the exactly same way that you differentiate x, but you have to multiply by dy dx. Because y is also a function of x. Make sense?
Yes, ma'am.
Yes, ma'am.
Mhm.
Yes.
Thank you. Let's go to example 1. That's implicit differentiation. So I hope we all know what implicit differentiation is now. Okay, new page. Oh, they say find dy dx. What do you think we'll do? Guys, just differentiate.
Yes.
Should we not first put everything onto one side of the equal side and then simplify it?
But
You don't
like
have
terms.
to. You don't have to.
Can't we
Aren't
say
we supposed to first differentiate the left-hand side and multiply it by dy over dx, and then also differentiate the right-hand side?
Yes, because right now you are saying the like terms. At some point, there won't be like terms. Like you are saying right now, take all the x's to the right hand side, take all the y's to the right hand side. That's fine. But at some point, x and y will be multiplying each other in such a way that you can't even differentiate them. For example, sine, like the one that was in the exam, sine xy. How do you differentiate that one? How do you separate that one?
You won't.
The product rule.
Won't.
It's a product.
You
No,
won't. You can't say, I'm going to take sine y to the left-hand side and take sine x to the left-hand side. Does it make sense?
Yes.
So with
Yes.
implicit, you just differentiate both sides. Remember in maths, what you do on your left, you do on your right. That's
Right.
what you learned in grade 3. And you have been shouting it in grade 3. What you do on your left, you do on your right. Today, you don't want to apply it. No, guys. It doesn't change. It remains the same. Come on. What you do, you are saying differentiate the left. Differentiate the left then. What is the derivative of the left-hand side?
3x squared
plus
y
4y
times
cubed.
dy
3x
dx.
squared plus
That's 4y cubed.
4y
4y
cubed
4y cubed.
times dy.
y dx.
dy dx.
Thank you.
But
But according to maths rule, grade 3, what we do on the left, we also?
Do on
do
the right.
on the
On the right.
Thank you. So what is the right side then?
3
3
minus
times dy dx.
3 minus
3?
0.
3.
minus 0.
3 minus 0.
3 minus 0.
We need the minus the 0 times dy dx.
Why are you
No,
timesing dy
no
dx?
y.
There's no y value.
No
You
y
already did it.
Oh, okay.
I say, why are you why are you timesing by dy dx? Why are you timesing by dy dx? So meaning every time you differentiate a y, you multiply by dy dx.
Noted.
Thank you. Okay. So what are we looking at here? Guys, you can't tell me from here we don't see what we're supposed to do. What are we supposed to do from here?
Move the 3x squared over to the other side, then
Thank-
you take a factor of 3 out of
Thank you. So you say 4y to the power of 3 dy over dx. 3 minus 3x squared. Guys, I'm not teaching you something that you don't know. If in financial maths in grade 10, 11, and 12, they say make I the subject of the formula because you are looking for I. Here you want dy over dx, meaning that you have to make dy over dx the subject of the formula. So how do you do that? You remove everything else. We know divide by 4y to the divide by 4. That. So therefore dy over dx is equals to what? 3, 1 minus x squared over 4y to the power of 3. Then you have performed what you call an implicit differentiation. Imagine, very easy. That's mad. Very easy. You don't have to stress yourself. Understand the concept. Understand your work. What are you doing? How are you doing it? Why are you doing it? Why are you doing that? Why are you multiplying y dy dx after differentiation? Because it's implicit differentiation. When do you apply implicit differentiation? It's because when you can't represent a function in terms of y, then it's an implicit equation. Like that. Come on, guys. Come on. Come on. Come on. Let's do example 2. Now I'm no longer conducting. Because now if I feel like also giving you a wrong answer, I'll give you a wrong answer. Because I think now you understand the implicit. So if I feel like I want to say x derivative of x squared is 5x, then I'll say that. Okay. Here it is. What do we do? What is this? What's going on here?
We should first
Why
simplify.
do we differentiate implicitly? Let's start there. You said implicit. Why do you differentiate implicitly?
Because
We have
we
no variables on both
Because
sides.
you
We
can't
can express y in
Thank you. Because you can't express y in terms of only functions of x on the right hand side. Guys, the reason why I'm teaching you this is because when the exam comes, everything is combined. Here you are able to see that we are doing implicit differentiation because you are doing the section implicit differentiation. But when you come to exam, it will be difficult to know which differentiation rules you'll be applying because everything will be combined. And I'm not going to do question 1 and go according to the study guide and say, because learning Newton 1 is standard, I mix up. Everything is everything. Fruit salad, you need to know which one is the pineapple. If you don't know how a pineapple looks, then that's a problem. So that's why I'm saying, why are we using implicit differentiation? Because we can express this function as y is equals to something x's only. We can't express it explicitly. Therefore, we use implicit differentiation. So let's start there. Now you need to be very careful here because something is something in here. I need one person to help me. Please. I need help here. Yes.
We're gonna apply the product rule since we have x cubed y, which is a product of x cubed multiplied by y, which means it's two functions.
Well done, 155%. We have x cubed y plus we have x y squared equals to 3x plus 7y. Now she's saying that because there are two functions, we're going to use the product rule. So help me. Then it will be what?
3x squared y.
3x squared y
So 3x squared y
plus x
Plus x squared
wait.
plus x cubed.
plus
X cubed
x cubed
Times
dy
y
dx
Times the derivative of y is 1, isn't it? Times
is
dy
times
over
dy
dx. If you
dx.
don't remember, differentiate the way you differentiate. Then on the right hand side is equals to?
You still have to do the second product.
This is included.
You see, I told you that my brain right now is going to do what it wants. If you don't give
Plus
me the right answer, my brain will decide for you. And it has decided. Plus x to the power of 3 dy over dx
Dx
plus
y squared
y squared plus
plus 2xy dy dx.
2xy dy over dx.
Yes.
Does it make sense to everyone?
yes.
Okay, then
It's equal to
grade 3 work. It's equals to what?
3 plus 7 dy dx.
You guys, are you mastering this? I want hundreds. Are we all together in this boat?
Yes.
Yes, ma'am.
Then what do? Do we leave it like this?
No.
No.
Thank you. We're looking for dy over dx. So what do we do?
Put dy dx on one side and
Like
everything
The
together.
function to dy dx on one side.
Thank you for singing. I didn't hear anything. So this
like
has
them.
dy over dx. So we say x to the power of 3 dy over dx. This one also has dy over x plus 2xy dy over dx. This also has dy over dx minus 7 dy over dx equals to, let's see, done. So this is 3. This one doesn't have dy over dx minus y squared. This one doesn't have dy over x minus 3x squared y. So then we take out, remember the taking out. We can only take out the dy of dx because we take it out here, we take it out here, we take it out here. So we remain with x3 plus 2xy minus 7 equals to 3 minus y squared minus 3x squared y. Therefore, you divide both sides. What you do on your left, you do on your right hand side. That is called numeracy, which you learned in your lower grades. 7 dy over dx. This is equals to 3 minus y squared minus 3x squared y over x to the power of 3 minus 2xy minus 7. Yes, that's implicit. Are we together? Are we together?
Yes.
Yes, ma'am. Yes.
Yes, ma'am.
Yeah.
It means I'm getting totals here. We are getting totals here.
Looks promising, ma'am. But hey, the way you set your questions sometimes, hey, hey.
I was so lenient this time around when I saw the questions. I was so lenient. I was like, oh Christ. But the exam, I'm not going to be lenient. I want you to understand your work. I don't know. Let me not talk. Maybe that day I might wake up and win 53 million lotto. If I win 53 million lotto, I'll ask you what is 7 plus 3?
Oh, that's like impossible almost.
Yes, example 3. Example 3. Example 3. Example 3. Example 3. Come on, let's do this. What are we doing here? And implicit. Okay, I know it's implicit because I can't express y equals to everything on the right hand side is x. So let's do it. Come on. Answers. I need answers, guys.
We're going to
We-
use
the
product rule
functions with y, we're gonna rule on them.
several times.
Okay, so let's give answers. So my first one says 3x squared, then minus, we are here now,
4xy
4xy
4xy.
plus
minus 2x squared.
Why am I getting plus? Minus
minus 2x squared dy dx.
dy over dx. Are we all together? Guys,
Yes.
thank you. Plus or minus? We are done. Now we come here.
Plus
Plus
Yes.
4y squared
Y squared.
plus 8x dy dx.
You see, you need to be careful. Minus or plus?
No.
Minus
4y squared plus 4x 2y.
Where are we, guys?
minus 8y
Minus 8y
minus 8 dy dx. Sorry, 8x dy dx.
8x dy
No, on the
over.
second function, there's something missing.
Wait.
The second function, the 4xy squared.
Okay, so we have 4xy squared. So
We-
this is so this will
we
be
have-
4y squared minus 8x. Yeah,
Y.
you're right.
Yes.
No, that's,
Do you see that?
aren't we applying the product rule on 4xy squared?
We are, you're right.
Yes, we are.
So it's 4xy squared. It equals to what? It will be equals to 4y
Oh, yes, I see.
squared minus, isn't that we differentiate x? Now we differentiate y. So it will be 4 times x times 2y times dy over dx. So this equals to minus 8xy dy over dx. Thank you. Are we all sorted?
Yes.
Okay.
Sorry,
I had a so. Are we all sorted? Can I continue?
why did you put the minus at the top there when it's a product rule and it should be a plus at the top?
Sorry. It's me being
For the
tired.
second term. Oh,
Yes. Isn't that's what we have here? We have a plus. You
yeah.
mean for the second term?
Yeah, so that's why I was just a bit confused because you had a minus over there when you were working out the second term.
Oh, yes. You mean the one that I corrected here right now?
Yeah.
Oh, no. Sorry. It's just being tired. You see, we wrote it correctly here.
Yeah.
Yes. Okay. And then now, what do we have? Plus 6, isn't it? Equals to 0. Are we all together there? Is
Yeah.
everything right, guys?
Yes.
Is everything right?
not make sure.
Why is not make sure now? But the procedure is right. We're doing the right thing. Should I continue?
Yes.
Yes,
So
ma'am.
we're definitely doing the right procedure here.
Yes, ma'am. I'm also getting the same thing.
Yes, because it's 3x squared minus 4xy minus 2x squared dy over dx plus 4y squared. Then it should be plus 8xy dy over dx. Where did the y? There was a y whip. Oh, it's here. That's 6. Then it's fine. Let's continue. If we make a mistake,
Sorry, you're
then
missing
yes.
the 8xy dy dx, not just 8x dy dx at the top there.
Yes, that's what I'm
What's
saying.
the
I'm
4y
missing.
squared?
Why did we? I did write it, but then it disappeared again. Yes. Okay, we sorted, ne? Guys, are we sorted?
Yes.
Yes.
Okay. So then we have a dy dx here. Me, I like starting with positive, eh? There's a dy dx here, so there's 8xy dy over dx. There's another dy dx here, minus 2x squared dy dx. There's another dx here, minus 8x dy dx. Then we have left with nothing. So let's take the other ones to the side. So there's minus 3x squared, which is this one, minus plus xy, which is this one, minus 4y squared, which is this one, plus 8y, which is this one, plus minus 6. So guys, someone is having music there. Can I just copy from the textbook? Fast. Where were we? Okay. So they said minus 2x squared dy over dx plus 8xy dy over dx minus 8x dy over dx, and everything else we take it to the left-hand side, minus 3x squared plus 4xy minus 4y squared plus 8y minus 6. Then we take out the common factors, which is dy. So dy over dx is minus 2x squared plus 8xy minus 8x, right? So this becomes minus 3x squared plus 4xy minus 4y squared plus 8y minus 6. Then you divide both sides, minus 2x squared plus 8xy minus 8x. Even this side, you divide minus 2x squared plus 8xy minus 8x. Therefore, my dy over dx is equals to minus 3x squared plus 4xy minus 4y squared plus 8y minus 6 over minus 2x squared plus 8xy minus 8x. Are we all together?
No, we lost.
Lost how?
Can you go on top, up?
Where?
Why did you say 4y squared, whereas you're gonna change it at the, when you say dy dx bracket, you say minus 4y squared?
Where? Which line?
The second line.
The second line. You're talking about this 4xy squared.
Yes.
Okay.
Then
So
on
this
the
4y
second line,
squared,
what you did,
it
you
becomes
said it's
here.
plus 4y squared. Yes. You said it's plus 4y squared. But when you take it from the book, it says minus 4y squared. Okay. Or you took it to the other side.
Yes.
Okay, thank you.
I'm not sure where I might have made a mistake, but I think it might be that.
I think it's
Did I
right,
lose
yeah.
someone? Because I think I'm also lost somewhere there. We might have made errors somewhere here. But do we understand the work, guys?
Yes, I think she was just confused about when you took it over to the other side of the equal sign, you changed your sign.
Okay.
That's all.
No, thank you. Thank you. So can we go to example 4 then? Which is the last one. Then we close.
Yes.
And this one I'll do it slowly. I think I rushed example 3, but this one I'll do it slowly. I do apologize. And if someone still doesn't understand it, please shout. I can explain it after class as others leave. Yeah. I do apologize for taking the remaining few minutes after class. I do apologize. I just wanted us to get to this. Okay, here we have this now. I'm not going to rush this example, so let's do it together. We have, so this is equals to guys?
Cos of
Numbers?
x
Cos x
So it's cos of x, yes.
minus
minus sine of y
sin
y
y
dx
dy dx
Yes.
as equals to dy dx
Hmm?
0
0
0
plus
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 dy dx
dx
dy dx plus 2x.
Do you see that? So here
Yes.
we have dy this side, so we can take it to the other side. So this is minus sine of y dy over dx minus dy over dx equals to 2x minus cos of x. So then we can take out dy dx because it's common. So dy over dx. Then we have minus sine of y minus 1, which is equals 2x minus cos of x. Right? So then we divide both sides. So minus sine of y minus 1. Divide both sides minus sine of y minus 1. So then this is dy over dx is equals to 2x minus cos of x. But you can also take out the negative if you want. You can leave it as this minus sine of y minus 1. But you can also take out the negative outside just to simplify it nicer. For me, I just like doing things in maths. So you can just say 2x minus cos of x over, take out the negative outside, sine of y, then plus, and then take the negative on top. So this is cos of x minus 2x over sine of y plus 1. Are we all together? Yes or no?
Yes.
Yes.
Oh, they even did that. Okay. So that's implicit, guys. And then you have activity 1 and you have post-test 2. Do you see that? So go do activity 1 and post-test 2. Those are practice questions. The solutions are there. If you're struggling with a question by Friday, send it so that it can be covered in class after class. Let's say after class, after covering the content of that particular. So that's implicit differentiation, and we done. So I'm stopping the recording unless there's a question related to the work that we have done. Then I can, yeah. Is there a question related to the work that we have done? If no, then I can stop the recording. Can I stop the recording?
no
Okay. Mr. Mudli, is it related to the work we have covered?
Yes, it is. Instead of
Yes.
writing dy dx, I normally just use y prime to make it easier to understand. So will I lose marks for doing that?
No, but but remember you were asked dy dx. So at the end, say therefore dy dx is equals to.
Okay.
Yeah, because remember, you're an engineer. If we ask you for a bridge, don't give us, I don't know, something else. You need to be precise. Therefore, it's dy over dx
Okay.
at the
Thank
end.
you.
Yes. I didn't stop the recording. I stopped the transcription. Stop the recording.